Hello and welcome to a new Hypi 101 session. In this session, we are going to learn more about the terminology used on Hypi platform. Specifically, we will discuss GraphQL. As one of the ways Hypi allows you to query data. This session is outlined as follows: the what, the why, and the how of GraphQL. Let's start with what GraphQL is. It is a query language first introduced by Facebook to build on the semantics of social graphs. In those graphs, users are represented by nodes and relations by edges. GraphQL in the wild is either considered to be code first or schema first. Hypi has taken the schema first approach. The schema defines all the data types that will be mapped to database tables behind the scenes. You can further annotate the schema or add functions that map to serverless functions, external APIs, or elsewhere. In Hypi, your schema is the control center of your app. This approach allows you to tailor the APIs to suit the front end or any other consumer of those APIs. The schema is also used to validate client requests. For example, if the schema declares a field to be an integer and the client populates the same field with a text value, then the validation fails and the GraphQL engine will throw an exception. You may wonder by now, what benefits GraphQL brings to the table? Traditionally, with RESTful APIs, the client had to send many requests to the backend server in order to populate the user interface. For example, there would be a request to get user info, another to retrieve user photos, one more to fetch his posts, and again to get his friends list. This is not the case anymore with GraphQL. The client can fetch all required data as fields and subfields on the user type in one request. The notion will become very clear as we dive deeper with hands-on examples. Even more, both the back end and the front end were very tightly coupled. The front end developers had to model their apps around what the back end offers. This made changing the back end a nightmare and usually resulted in breaking the front end code. In this context, the word front end refers to web, mobile, IoT applications, or any other consumer of the APIs. Another side effect of the traditional approach was that the back-end servers returned all the available fields on any object, regardless of whether the front-end client had asked for it. In GraphQL, the front end takes lead and defines only the fields and subfields that are needed. This reduces network bandwidth consumption and makes apps faster with a better user experience. In a nutshell, GraphQL gives the web, mobile, and IoT developers the flexibility to define their own data models and linking different types as fit for the application flow. And all of this without even being constrained to what the backend offers. A good understanding of what GraphQL is, a good understanding of GraphQL will allow you to get the most out of the features that Hypi provides. In the next couple of slides, I shall break the GraphQL schema down to you. In Hypi, the available schema constructs are types, enums, interfaces, and directives. A type is mapped to a database table by default, but you can map it to anything you want, for example, an external API response or a serverless function. The enum is used to restrict the values a field can take to the ones defined in the enum object. Interfaces maximize code reusability by sharing common fields and allow new types to implement the interface. Directives define the behavior of fields, such as unique or required, to name a few. There is a dedicated lecture on directives later in this course. GraphQL makes use of the notion of query to define functions that will retrieve values from the back end. That is, functions that don't have side effects, both built-in and custom. On the other hand, the notion of mutation wraps the functionality of inserting or updating the back-end data. That is, functions that cause side effects. In Hypi, subscriptions are also available via WebSockets that retrieve live streams of updates from the backend, and that is real-time applications such as chats, instant messaging, stock markets, digital booking services, or even interactive games, and a lot more. Now that we have defined the essential three elements of a GraphQL schema that were query, mutation, and subscriptions, let's move on to supplementary concepts that are also available on Hypi. Directives are syntax annotations that can be used to enrich the behavior of fields or types. Their functions are endless, ranging from simple validation to defining serverless functions and beyond. Hypi has also designed a query language, RQL, that is similar to SQL to facilitate filtering and sorting of data when executing GraphQL queries. It is better demonstrated with examples in the hands-on exercise that follows. To avoid any misconception, Let's emphasize that a database is not the only data source available on Hypi. You can retrieve data from third-party APIs, cloud services, or any other source. In this session, we have learned about the what, the why, and the how of GraphQL. Thank you and see you in the next session.